Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You have Google Cloud Dataflow streaming pipeline running with a Google Cloud Pub/Sub subscription as the source. You need to make an update to the code that will make the new Cloud Dataflow pipeline incompatible with the current version. You do not want to lose any data when making this update. What should you do? The options are: Option A, update the current pipeline and use the drain flag. Option B, update the current pipeline and provide the transform mapping JSON object. Option C, create a new pipeline that has the same Cloud Pub/Sub subscription and cancel the old pipeline. Option D, create a new pipeline that has a new Cloud Pub/Sub subscription and cancel the old pipeline.
To arrive at the correct answer, we focus on the keywords: Google Cloud Dataflow Streaming Pipeline, incompatible with the current version, do not want to lose any data.
The correct answer is Option A, update the current pipeline and use the drain flag.
Why is this correct? A. Using the drain flag gracefully stops the pipeline by completing the processing of all currently buffered and in-flight data, ensuring no data is lost before you deploy the incompatible update. Why are the others incorrect? B. Transform mapping JSON objects are used to rename steps during in-place compatible updates, but this approach is not supported when the code update is incompatible. C. Canceling the old pipeline immediately halts execution, which results in the loss of any in-flight or buffered data currently being processed. D. Canceling the pipeline causes the loss of in-flight data, and switching to a new subscription abandons any unprocessed messages remaining in the original subscription.
Your company is running their first dynamic campaign, serving different offers by analyzing real-time data during the holiday season. The data scientists are collecting terabytes of data that rapidly grows every hour during their 30-day campaign. They are using Google Cloud Dataflow to pre-process the data and collect the feature, signals, data that is needed for the machine learning model in Google Cloud Bigtable. The team is observing suboptimal performance with reads and writes of their initial load of 10 terabytes of data. They want to improve this performance while minimizing cost. What should they do? The options are: Option A, redefine the schema by evenly distributing reads and writes across the row space of the table. Option B, the performance issue should be resolved over time as the size of the big data cluster is increased. Option C, redesign the schema to use a single row key to identify values that need to be updated frequently in the cluster. Option D, redesign the schema to use row keys based on numeric IDs that increase sequentially per user viewing the offers.
To arrive at the correct answer, we focus on the keywords: Google Cloud Bigtable, observing suboptimal performance with reads and writes, improve this performance while minimizing cost.
The correct answer is Option A, redefine the schema by evenly distributing reads and writes across the row space of the table.
Why is this correct? A. Evenly distributing reads and writes across the row space prevents hotspotting in Bigtable. A balanced schema ensures the workload is spread across multiple nodes, improving read/write performance effectively while avoiding the additional costs of simply scaling up the cluster. Why are the others incorrect? B. Increasing the cluster size will increase costs, contradicting the requirement to minimize cost. Also, if the schema causes hotspotting, more nodes won't effectively solve the performance issue. C. Using a single row key for frequently updated values creates a severe hotspot on a single node, which severely degrades performance rather than improving it. D. Using sequential numeric IDs as row keys causes all new data to be written to a single tablet consecutively, creating a hotspot that severely degrades write performance.
Your software uses a simple JSON format for all messages. These messages are published to Google Cloud Pub/Sub, then processed with Google Cloud Dataflow to create a real-time dashboard for the CFO. During testing, you notice that some messages are missing in the dashboard. You check the logs, and all messages are being published to Cloud Pub/Sub successfully. What should you do next? The options are: Option A, check the dashboard application to see if it is not displaying correctly. Option B, run a fixed dataset through the Cloud Dataflow pipeline and analyze the output. Option C, use Google Stackdriver monitoring on Cloud Pub/Sub to find the missing messages. Option D, switch Cloud Dataflow to pull messages from Cloud Pub/Sub instead of Cloud Pub/Sub pushing messages to Cloud Dataflow.
To arrive at the correct answer, we focus on the keywords: messages are published to Google Cloud Pub/Sub, processed with Google Cloud Dataflow, messages are missing in the dashboard, all messages are being published to Cloud Pub/Sub successfully.
The correct answer is option B, run a fixed dataset through the Cloud Dataflow pipeline and analyze the output.
Why is this correct? B, since messages are successfully published to Pub/Sub, the next logical step in debugging the pipeline is to isolate Cloud Dataflow. Running a fixed dataset allows you to verify if the Dataflow transformations are dropping or mishandling the messages before they reach the dashboard. Why are the others incorrect? A, while possible, checking the dashboard first is less likely to isolate the issue than testing the Dataflow pipeline, which is the complex transformation layer sitting between Pub/Sub and the dashboard. C, the logs already confirm that messages are successfully published to Cloud Pub/Sub, so monitoring Pub/Sub will not provide further insights into why they are missing downstream. Why are the others incorrect? D, switching the delivery mechanism between Pub/Sub and Dataflow does not address the root cause of missing messages. The issue is likely in the processing logic, not the ingestion method.
Your company has recently grown rapidly and now ingesting data at a significantly higher rate than it was previously. You manage the daily batch MapReduce analytics jobs in Apache Hadoop. However, the recent increase in data has meant the batch jobs are falling behind. You were asked to recommend ways the development team could increase the responsiveness of the analytics without increasing costs. What should you recommend they do? The options are: Option A, rewrite the job in Pig. Option B, rewrite the job in Apache Spark. Option C, increase the size of the Hadoop cluster. Option D, decrease the size of the Hadoop cluster but also rewrite the job in Hive.
To arrive at the correct answer, we focus on the keywords: batch MapReduce analytics jobs in Apache Hadoop, increase the responsiveness of the analytics without increasing costs.
The correct answer is option B, rewrite the job in Apache Spark.
Why is this correct? B, Apache Spark processes data in memory, significantly reducing disk I/O compared to traditional MapReduce. This vastly improves batch job execution speed and responsiveness on the same hardware, achieving the goal without increasing cluster costs. Why are the others incorrect? A, Apache Pig primarily translates scripts into MapReduce jobs, offering no inherent performance improvement to meet the increased responsiveness requirement. C, expanding the size of the Hadoop cluster involves adding more hardware, which directly violates the constraint of not increasing costs. D, decreasing the cluster size reduces available compute resources, likely degrading performance further, and rewriting in Hive alone does not provide the massive performance leap needed to offset this.
You work for a large fast food restaurant chain with over 400,000 employees. You store employee information in Google BigQuery in a user's table consisting of a first name field and a last name field. A member of IT is building an application and asks you to modify the schema and data in BigQuery so the application can query a full name field consisting of the value of the first name field concatenated with a space, followed by the value of the last name field for each employee. How can you make that data available while minimizing cost? The options are: Option A, create a view in BigQuery that concatenates the first name and last name field values to produce the full name. Option B, add a new column called full name to the users table. Run an update statement that updates the full name column for each user with the concatenation of the first name and last name values. Option C. Create a Google Cloud Dataflow job that queries BigQuery for the entire users table, concatenates the first name value and last name value for each user, and loads the proper values for first name, last name, and full name into a new table in BigQuery. Option D. Use BigQuery to export the data for the table to a CSV file. Create a Google Cloud Dataproc job to process the CSV file and output a new CSV file containing the proper values for first name, last name, and full name. Run a BigQuery load job to load the new CSV file into BigQuery.
To arrive at the correct answer, we focus on the keywords, modify the schema and data, query a full name field, minimizing cost.
The correct answer is option A. Create a view in BigQuery that concatenates the first name and last name field values to produce the full name.
Why is this correct? A. Creating a view in BigQuery is a free metadata operation. It avoids the compute and storage costs of duplicating data or modifying the existing table, perfectly satisfying the requirement to minimize cost. Why are the others incorrect? B. Running an update modifies the underlying data, incurring processing costs and potentially increasing storage costs, which does not minimize cost compared to a view. C. Using Dataflow to rewrite the table incurs unnecessary and significant compute and storage costs for a simple concatenation task. D. Exporting data, processing it with Dataproc, and reloading it is an overly complex pipeline that incurs high compute, storage, and data movement costs.
You are deploying a new storage system for your mobile application, which is a media streaming service. You decide the best fit is Google Cloud Data Store. You have entities with multiple properties, some of which can take on multiple values. For example, in the entity movie, the property actors and the property tags have multiple values, but the property date released does not. A typical query would ask for all movies with actor equals actor name ordered by date _ released, or all movies with tag equals comedy ordered by date _ released. How should you avoid a combinatorial explosion in the number of indexes? The options are: Option A, manually configure the index in your index config as follows. Option B, manually configure the index in your index config as follows. Option C, set the following in your entity options: exclude _ from _ indexes equals actors, tags. Option D, set the following in your entity options: exclude _ from _ indexes equals date _ published.
To arrive at the correct answer, we focus on the keywords, Google Cloud Data Store, multiple properties, some of which can take on multiple values, avoid a combinatorial explosion in the number of indexes.
The correct answer is option A. Manually configure the index in your index config as follows.
Why is this correct? A. Manually configuring the index allows you to specify exactly which composite indexes are required, preventing Datastore from automatically generating every possible combination of array values and causing an index explosion. Why are the others incorrect? B. This option represents an incorrect manual configuration that fails to properly address or prevent the index explosion for the multiple value properties. C. Excluding actors and tags from indexes would break the application's ability to query movies by actor or tag, which is a stated requirement. D. Excluding the date property from indexes would prevent ordering query results by date, breaking the required query functionality. Also, the property is named date released, not date _ published.
You work for a manufacturing plant that batches application log files together into a single log file once a day at 2 a.m. You have written a Google Cloud Dataflow job to process that log file. You need to make sure the log file is processed once per day as inexpensively as possible. What should you do? The options are: Option A, change the processing job to use Google Cloud Dataproc instead. Option B, manually start the Cloud Dataflow job each morning when you get into the office. Option C, create a cron job with Google App Engine cron service to run the Cloud Dataflow job. Option D, configure the Cloud Dataflow job as a streaming job so that it processes the log data immediately.
To arrive at the correct answer, we focus on the keywords: once a day at 2 a.m., Google Cloud Dataflow job, processed once per day, inexpensively as possible.
The correct answer is option C, create a cron job with Google App Engine cron service to run the Cloud Dataflow job.
Why is this correct? C. App Engine cron service is a fully managed task scheduler that can automatically trigger the Cloud Dataflow job daily at 2 a.m., meeting the requirements of reliable scheduling and processing once per day as inexpensively as possible. Why are the others incorrect? A. Switching to Google Cloud Dataproc requires rewriting the job and managing a cluster, adding unnecessary overhead without solving the scheduling requirement. B. Manually starting the job is inefficient, error-prone, and not a viable automated, scalable solution for daily operations. D. A streaming job runs continuously 24/7, which incurs significantly higher costs than a daily batch job, violating the requirement to operate as inexpensively as possible.
You work for an economic consulting firm that helps companies identify economic trends as they happen. As part of your analysis, you use Google BigQuery to correlate customer data with the average prices of the 100 most common goods sold, including bread, gasoline, milk, and others. The average prices of these goods are updated every 30 minutes. You want to make sure this data stays up to date so you can combine it with other data in BigQuery as cheaply as possible. What should you do? The options are: Option A, load the data every 30 minutes into a new partition table in BigQuery. Option B, store and update the data in a regional Google Cloud Storage bucket and create a federated data source in BigQuery. Option C, store the data in Google Cloud Data Store. Use Google Cloud Dataflow to query BigQuery and combine the data programmatically with the data stored in Cloud Data Store. Option D, store the data in a file in a regional Google Cloud Storage bucket. Use Cloud Dataflow to query BigQuery and combine the data programmatically with the data stored in Google Cloud Storage.
To arrive at the correct answer, we focus on the keywords: Google BigQuery, average prices of the 100 most common goods sold, updated every 30 minutes, combine it with other data in BigQuery, as cheaply as possible.
The correct answer is option B, store and update the data in a regional Google Cloud Storage bucket and create a federated data source in BigQuery.
Why is this correct? B. A federated data source allows BigQuery to query data directly from cloud storage without ingestion, providing a highly cost-effective solution for frequently updated, small datasets while seamlessly combining it with other BigQuery data. Why are the others incorrect? A. Loading data into a new partition table every 30 minutes increases storage and operational costs, failing to meet the requirement to perform the task as cheaply as possible. C. Introducing Cloud Data Store in Dataflow adds unnecessary architectural complexity and significantly increases infrastructure costs compared to native BigQuery federated queries. D. Using Cloud Dataflow to programmatically combine data from cloud storage and BigQuery is overly complex, resource-intensive, and much more expensive than a simple federated query.
You are designing the database schema for a machine learning-based food ordering service that will predict what users want to eat. Here is some of the information you need to store: the user profile, what the user likes and doesn't like to eat, the user account information, name, address, preferred meal times, the order information, when orders are made, from where, to whom. The database will be used to store all the transactional data of the product. You want to optimize the data schema. Which Google Cloud Platform product should you use? The options are: Option A, BigQuery. Option B, Cloud SQL. Option C, Cloud Bigtable. Option D, Cloud Data Store.
To arrive at the correct answer, we focus on the keywords: user profile, user account information, order information, transactional data, optimize the data schema.
The correct answer is option B, Cloud SQL.
Why is this correct? B. Cloud SQL is a relational database ideal for handling structured transactional data, such as user profiles and orders, and allows for schema optimization through normalization. Why are the others incorrect? A. BigQuery is a data warehouse designed for analytics and querying massive datasets, not for serving as a primary operational database for transactional data. C. Cloud Bigtable is a NoSQL wide column store optimized for low latency, high throughput workloads like time series data, not for relational transactional data. D. Cloud Data Store is a NoSQL document database which does not natively support the relational schema optimization and complex joins typical of Cloud SQL.
Your company is loading comma-separated values, CSV, files into Google BigQuery. The data is fully imported successfully. However, the imported data is not matching byte to byte to the source file. What is the most likely cause of this problem? The options are: Option A, the CSV data loaded in BigQuery is not flagged as CSV. Option B, the CSV data has invalid rows that were skipped on import. Option C, the CSV data loaded in BigQuery is not using BigQuery's default encoding. Option D, the CSV data has not gone through an ETL phase before loading into BigQuery.
To arrive at the correct answer, we focus on the keywords Google BigQuery, imported data is not matching byte to byte.
The correct answer is option C. The CSV data loaded in BigQuery is not using BigQuery's default encoding.
Why is this correct? C. BigQuery uses UTF-8 encoding by default. If the source CSV uses a different encoding, it may import successfully, but the underlying byte representation will differ, causing a byte-to-byte mismatch. Why are the others incorrect? A. If the data was not flagged as CSV, the import process would likely fail or parse incorrectly, rather than succeeding with only a byte-to-byte mismatch. B. Skipping invalid rows would cause a row count mismatch. Encoding differences are the primary reason for byte-level discrepancies in successfully imported text data. D. An ETL phase is not required to load data into BigQuery. Its absence does not inherently cause a byte-to-byte mismatch during a successful import.
Your company produces 20,000 files every hour. Each data file is formatted as a comma-separated values, CSV, file that is less than 4 kilobytes. All files must be ingested on Google Cloud Platform before they can be processed. Your company site has a 200 milliseconds latency to Google Cloud, and your internet connection bandwidth is limited as 50 megabits per second. You currently deploy a secure FTP, SFTP, server on a virtual machine in Google Compute Engine as the data ingestion point. A local SFTP client runs on a dedicated machine to transmit the CSV files as is. The goal is to make reports with data from the previous day available to the executives by 10 a.m. each day. This design is barely able to keep up with the current volume. Even though the bandwidth utilization is rather low, you are told that due to seasonality, your company expects the number of files to double for the next 3 months. Which 2 actions should you take? Choose 2. The options are: Option A, introduce data compression for each file to increase the rate of file transfer. Option B, contact your Internet Service Provider, ISP, to increase your maximum bandwidth to at least 100 megabits per second. Option C, redesign the data ingestion process to use SITL tool to send the CSV files to a storage bucket in parallel. Option D, assemble 1,000 files into a tape archive, TAR, file. Transmit the TAR files instead, and disassemble the CSV files in the cloud upon receiving them. Option E, create an S3-compatible storage endpoint in your network, and use Google Cloud Storage Transfer Service to transfer on-premises data to the designated storage bucket.
To arrive at the correct answer, we focus on the keywords 20,000 files every hour, less than 4 kilobytes, 200 milliseconds latency, bandwidth utilization is rather low, number of files to double.
The correct answers are option C. redesign the data ingestion process to use SUDL tool to send the CSV files to a storage bucket in parallel. And option D, assemble 1000 files into a tape archive (TAR) file. Transmit the TAR files instead, and disassemble the CSV files in the cloud upon receiving them.
Why is this correct? C. SUDL enables parallel, multi-threaded uploads directly to cloud storage, significantly improving throughput for many small files and bypassing the latency bottlenecks of the sequential SFTP process. D. Combining small files into a larger TAR archive reduces the number of network round trips and protocol overhead, effectively minimizing the impact of the 200 milliseconds latency. Why are the others incorrect? A. Compressing already small 4 kilobytes files provides minimal size reduction and does not resolve the high network round-trip overhead caused by transmitting thousands of files individually. B. Increasing bandwidth is ineffective because the current 50 megabits per second bandwidth utilization is already low. The bottleneck is network latency and connection overhead for small files. E. Creating an S3 compatible endpoint introduces unnecessary infrastructure complexity for this scenario and does not directly solve the latency overhead of small file transfers.
You are choosing a NoSQL database to handle telemetry data submitted from millions of Internet of Things (IoT) devices. The volume of data is growing at 100 terabytes per year, and each data entry has about 100 attributes. The data processing pipeline does not require atomicity, consistency, isolation, and durability, ACID. However, high availability and low latency are required. You need to analyze the data by querying against individual fields. Which 3 databases meet your requirements? Choose 3. The options are: Option A, Redis. Option B, HBase. Option C, MySQL. Option D, MongoDB. Option E, Cassandra. Option F, HDFS with Hive.
To arrive at the correct answer, we focus on the keywords: NoSQL database, 100 terabytes per year, 100 attributes, does not require atomicity, consistency, isolation, and durability, ACID, high availability and low latency are required. Analyze the data by querying against individual fields.
The correct answers are option B, HBase, and option D, MongoDB, and option E, Cassandra.
Why is this correct? B. HBase is a highly scalable, wide-column NoSQL database suitable for massive datasets, offering high availability, low latency, and allowing queries on specific column fields. D. MongoDB is a scalable document-based NoSQL database that provides high availability, handles large data volumes, and supports rich queries against individual attributes. E. Cassandra is a distributed wide-column NoSQL database designed for high availability and low latency at scale, perfectly suited for massive telemetry data and querying specific fields. Why are the others incorrect? A. Redis is an in-memory data store, which makes it prohibitively expensive and technically impractical to store 100 terabytes of data per year. Why are the others incorrect? C. MySQL is a relational database management system that provides ACID compliance, whereas the requirement specifically asks for a NoSQL database. F. HDFS with Hive is designed for batch processing and data warehousing, which results in high latency, violating the low latency requirement.
You are training a spam classifier. You notice that you are overfitting the training data. Which 3 actions can you take to resolve this problem? Choose 3. The options are: Option A, get more training examples. Option B, reduce the number of training examples. Option C, use a smaller set of features. Option D, use a larger set of features. Option E, increase the regularization parameters. Option F, decrease the regularization parameters.
To arrive at the correct answer, we focus on the keywords: overfitting the training data.
The correct answers are option A, get more training examples, and option C, use a smaller set of features, and option E, increase the regularization parameters.
Why is this correct? A. Getting more training examples helps the model generalize better by providing a more representative sample of the underlying data distribution, reducing variance. C. Using a smaller set of features reduces model complexity, mitigating the curse of dimension.
You are implementing security best practices on your data pipeline. Currently, you are manually executing jobs as the project owner. You want to automate these jobs by taking nightly batch files containing non-public information from Google Cloud Storage, processing them with a Spark Scala job on a Google Cloud Dataproc cluster, and depositing the results into Google BigQuery. How should you securely run this workload? The options are: Option A, restrict the Google Cloud Storage bucket so only you can see the files. Option B, grant the project owner role to a service account and run the job with it. Option C, use a service account with the ability to read the batch files and to write to BigQuery. Option D, use a user account with the project viewer role on the Cloud Dataproc cluster to read the batch files and write to BigQuery.
To arrive at the correct answer, we focus on the keywords: security best practices, automate these jobs, Google Cloud Storage, Google Cloud Dataproc cluster, depositing the results into Google BigQuery, securely run this workload.
The correct answer is option C, use a service account with the ability to read the batch files and to write to BigQuery.
Why is this correct? C. Service accounts are the recommended way to automate workloads securely in Google Cloud, adhering to the principle of least privilege by granting only necessary permissions to read from cloud storage and write to BigQuery. Why are the others incorrect? A. Restricting bucket access to yourself does not help automate the workload securely, as automation should rely on an appropriately scoped service account rather than a personal user account. B. Granting the project owner role to a service account violates the principle of least privilege by providing excessive and unnecessary permissions across the entire project. D. User accounts should not be used for automated workloads, and the project viewer role lacks the necessary permissions to write data to BigQuery.
You are using Google BigQuery as your data warehouse. Your users report that the following simple query is running very slowly. No matter when they run the query, select country, state, city from, myproject, myDataset.mytable. Group by country. You check the query plan for the query and see the following output in the read section of stage 1. What is the most likely cause of the delay for this query? The options are: Option A, users are
To arrive at the correct answer, we focus on the keywords: group by country, read section of stage 1.
The correct answer is option D, most rows in the myproject, myDataset.mytable table have the same value in the country column, causing data skew.
Why is this correct? D. The query groups by country. If most rows share the same country, this creates data skew, forcing one worker node to process a disproportionate amount of data. This imbalance causes the delay, reflected by a significant difference between average and max worker times in the query plan. Why are the others incorrect? A. High concurrency increases initial wait times in the queue before execution begins, rather than causing a skewed execution delay within a specific processing stage. B. While too many partitions can affect metadata reading, it does not explain the processing imbalance and delay during the group by phase shown in the execution plan. C. Having many null values in non-grouped columns, state or city, does not cause data skew during the grouping phase and wouldn't lead to this type of execution delay.